math problem's really kicking my butt. I wish I had someone here to help me with it.
Did somebody summon the math genie?
Yes, Math Genie. I need some help on this physics-related math problem.
I will grant you 3 math-related wishes.
Let's see. I would like a LaCroix, a box of Cheez-Its, and for you to help me with this math problem.
Well, you're in luck.
Thanks, Math Genie.
No problem. Now let's get started on the physics-related math problem.
In this video, we will go over the relationship between the scientific field of physics and mathematics. You see, without math, physics would be really hard, harder than it already is. Mathematics is often described as an essential tool for physics. Mathematics is what allows physical things and the motion of physical things to be measured, and physics is the field of science in which those measurements fall under. Today we will focus on the main branch of mathematics physics uses, calculus, and how it helps physicists and everyone really. We will go over some demos with math and physics to give a deeper understanding of what we mean. Stated previously, mathematics is a language of physics, let alone a language of science, but more specifically, the math branch of calculus is what fuels physics. Calculus was discovered in the mid-1600s by Sir Isaac Newton. It was discovered when he came to realization, when an apple falls from a tree, does it take the moon with it? It seems silly, but this problem led the man to create a whole subsection of math, and a pretty popular one for that matter. Calculus is a very difficult and confusing math course. I, on the other hand, like to think of it as algebra on steroids. You see, this first graph here is an example of a simple algebra problem, or geometry problem. It's finding x, a straight side, with other straight sides. The two sides are known. You can find x easily using the Pythagorean theorem. And over here we have an example of a calculus problem, a natural looking line with all these curves and turns. See, as opposed to this one, which is straight and easy to find the missing side. But over here, x is curved. We can't solve it with normal algebra, so we gotta use calculus. Several examples of calculus helping us solve mystery in the real world. Physics. These are definitely not all of them. This first example is finding length of curved things like bridges, mountains, tree branches, like natural things to find in the wild. And that's exactly what physics deals with, is natural motions and lengths. So right here is an example of a sailboat, finding the curved sail side. And we know that's 200 yards. So I'm not going to go over it, but that's just an example. The second example we have here is finding average velocity, position, time, etc. of an object falling for something. This is what most people think of when they think of physics, and it is the main gist of physics. And there are many, many more examples that we don't have time for. Here we have an example of physics problem that fits in nicely with what we have been explaining. It's not necessarily focusing on calculus though. In our problem here, a man has thrown an object off of a really tall building, exactly 1,542 feet tall. Don't ask me why I picked that number. We want to find the average velocity, so here we have to find the position of when the object is at 2 seconds after being dropped and 3 seconds.
Yeah.
These are the equations we will be using. The first one here is the position equation. This is st equals negative 16t squared plus v sub naught t plus h sub naught. V sub naught represents the initial velocity of the object, which is 0 in this situation. H sub naught represents the initial height, which is 1,542 feet. And this is the equation for velocity, vt equals negative 32t. It's a good one to note. So if you plug in our 2 times to the position equation, S2 equals negative 16, 2 squared, plus 1,542 plus 0, because 0 is the initial velocity. So it's just whatever it is, it's multiplied by 0. This gets us 1,478. So at 2 seconds, the object is at 1,478 feet. Now if we go down and plug it in with our number 3, we go S3 equals negative 16, 3 squared, plus 1,542 plus 0. It ends up that at 3 seconds, the object is at 1,398 feet. This leaves us with 2 points, as if they were on a graph or a coordinate plane. 2, 1478, and 3, 1398. This will lead into finding the average velocity. For the last step, we need to apply a simple slope formula. So for the average velocity, we're taking 2 points in the coordinate plane and we're finding the slope, which turns out to be the average velocity. So it would be s of 3 minus s of 2 over 3 minus 2. These are the y values, these are the x values. We then plug in the actual values, 1398 minus 1478 over 3 minus 2, which equals 1. From there, that whole thing turns out to be negative 80 over 1, which is negative 80 feet per second. That's the average velocity, and it would be 80 feet per second if we're talking. So you may now be wondering, why did we choose to do a video on physics and its relation to math? Well, besides from it being an assignment, we chose to do this video because we were fascinated in how math and science relate so much, and physics is a prime example of that fact. This has enhanced our understanding of math and science, physics specifically, by making us realize that math is truly the language of science, and without math, science wouldn't be understandable. Same goes for the other way around. Well, thanks for watching our video, and have a great day.